In this math tutorial today, we'll be having a look at the order of operations, how it's used, what it is, and also how to use it optimally so that you don't get confused, especially when the calculations get a little bit more complex. Before we start, give me a shout out, like the video, subscribe to the channel, and also check your bell notifications so that you can receive any future videos that I will release. Let's jump in. So when we talk about the order of operations, we actually refer to what is called BODMAS. And each letter of BODMAS stands for a certain operation that we are going to perform in a certain order. Let's go have a look at what that is. So BODMAS. And each one of these letters means something. B for brackets, O for orders, D for division, M for multiplication, A for addition, and S for subtraction. So there we have our brackets, our orders. Orders include to the power of or even roots. And then we've got the division operator, the multiplication operator, the addition operator, and the subtraction operator. We also get another word, PEMDAS. And PEMDAS and BODMAS is exactly the same. PEMDAS is just another way of saying the order of operations, depending on in which part of the world you live in. B and O is replaced by P and E. P for parentheses, same as brackets, and E for exponents, same as orders. Let's hop in and do some calculations, starting from simpler and working our way down to more difficult questions. The first one we're going to do is to calculate 5 plus 2 plus 1 plus 0 plus 6. Now, we can see that the operation that we are going to perform is all addition, meaning that we don't really need to take BODMAS into account, just basically add from left to right, like reading a sentence. So we're going to start by saying 5 plus 2, that's 7. Then we're going to add 7 plus 1, which will be 8. And then we're going to add 0. Now, 0 is an identity in mathematics, and this identity tells us that anything added or subtracted with 0 stays unchanged. So I'm going to still be left with 8. And now I just need to add 6, and my final answer will be 40. Our next calculation is to calculate 5 minus 2 plus 1 minus 0 plus 6. Here we have mixed operations, but they're still in the same operator group, meaning addition and subtraction. So we're just going to again add from left to right, like reading a sentence. We're going to start by saying 5 minus 2 is 3. 3 plus 1 is 4. And again, we have the identity, 4 minus 0. So anything added or subtracted with 0 stays unchanged. And then 4 plus 6 will equal 10. If we now have a look at calculating something like 5 times 2 times 0 times 2 times 1, we'll notice that the operation is still the same. Now it's just multiplication. So we're just going to multiply again from left to right, like again reading a sentence. So we're going to say 5 times 2 is 10. And now we've got 10 times 0. 10 times 0 is another identity. And this identity tells us that anything times 0 equals 0. So 10 times 0 will be 0. Now, again, I'm going to apply that identity because I've got 0 times 2. Anything times 0 equals 0. 0 and then times 1 will again be 0. So this one reduces to literally nothing. Having a look at our next calculation, we have 5 times 2 times 6 times 1 times 2. Again, we've only got one operation to complete, and that's multiplication. So we're again going to work from left to right, like reading a sentence. Starting with 5 times 2 is 10. 10 times 6 is 60. And now we've got 60 times 1, which is another identity. And this identity tells us that anything times 1 equals the same anything. 60 times 1 will be 60. And then 60 times 2 will be 120. Now let's calculate 3 plus 5 times 2 minus 4. Now we have operations from different groups. We've got a multiplication and we've got addition and subtraction. Now BODMAS really is going to come into play. So I'm first going to work with my multiplication because multiplication comes before addition and subtraction in the order of operations. So I'm going to use BODMAS. I'm going to multiply first. 5 times 2 will equal 10. And notice that I'm still writing out the same sentence. 3 plus, now 5 times 2 is 10. So I've changed that now to my answer, which is 10 minus 4. Now I'm going to use BODMAS again, but this time the operations are all in the same group, meaning that I'm just going to work from left to right to complete this. So I'm going to add and subtract. 3 plus 10 is 13, and 13 minus 4 is 9. Let's now calculate 3 plus 2 in brackets times 4 minus 1 in brackets. Now it becomes a little bit more complex. Now I've got brackets or parentheses to take note of as well. BODMAS tells me I first have to work with my brackets. So I'm going to use BODMAS and I'm going to use it in my first bracket and then I'm going to do my second bracket. So I'm going to say 3 plus 2 is 5 times, and then I'm just going to complete my sentence, bracket 4 minus 1. I haven't worked with that yet, so I can't yet reduce it. Now, one thing you should notice is that I haven't written down the brackets after I've done 3 plus 2. Why? Because I've done the order or the calculation within that bracket, meaning that I can now just let go of the bracket. Now I'm going to work with my second bracket. I'm going to write 5 times, and then 4 minus 1 is 3. Again, I don't need to write down those brackets again. And now I'm going to use BODMAS and I'm going to multiply since this is my last operation to complete. So 5 times 3 will equal 15. Let's now calculate 2 plus 3 plus 5 in brackets to the power of 2 divided by 64. Now I've got a full set of order of operations. I've got brackets, I've got orders, I've got division from the division and multiplication group, and I've got addition from the addition and subtraction group. So here I'm going to again work with inside of my brackets first because BODMAS tells me I have to do that first. So I'm going to say 3 plus 5 is 8. Notice though, I am writing down the brackets still. So we are not done with the calculation since we still have to the power of 2. So I can't yet throw away that bracket. So now I'm going to say 8 to the power of 2 is 8 times 8, that's 64. So now I'm going to use my orders. 2 plus 64 divided by 64, completing that sentence. And now I'm going to use BODMAS and I'm going to divide. 64 divided by 64 equals 1. So now I have 2 plus 1. Now I'm going to just add together, and my final answer will be 3. Next up, let's calculate in brackets, everything in brackets, 7 plus, now I've got a nested bracket. Inside the nested bracket, I have 8 minus 2 times 3. And then outside of a nested bracket, I've got minus 5. And then everything in the big bracket. And then outside of that big bracket, I've got plus 1. So here we have an example of a nested bracket setup. BODMAS tells me I have to use brackets, but which one? Well, I'm always going to start from the most nested bracket first. In this case, I've got only one nested bracket within a larger bracket, meaning I'm going to work with that first. Now I need to go and check my order of operations within that nested bracket as well. I can see I've got two different sets of operators. I've got minus and I've got multiply, meaning I need to do multiply first. So what we're going to do is we're going to multiply 2 times 3 first. We're not going to get rid of that bracket because we haven't completed all the operations within that bracket just yet. So remember, we are not done with the calculation, so brackets are safe and still necessary. Now I'm going to continue with that nested bracket by subtracting. 8 minus 6 will be 2. And now I can get rid of my bracket because I've done the calculation inside of that nested bracket. Now I'm going to work with what's left in the bigger bracket. So now I'm going to continue with my outer brackets, and I'm going to add and subtract. 7 plus 2 is 9. Minus 5 is 4. Get rid of that bracket. I'm done with that. And now I've got plus 1, which were outside of a larger bracket group. 4 plus 1, using BODMAS, adding is 5. So these get a little bit more complex and more tricky as we go along. We have to really apply ourselves and really make sure that we keep track of what we are doing and also keep track of the structure that we need to follow. Another way of writing brackets is that we don't just need to use round brackets, we can use square brackets. So in order to distinguish a little bit better from the brackets, I can use the larger bracket system. I can use square brackets like this instead of using round brackets. This might work for you a little bit better, or you might get a scenario within a test where they use two different bracket sets. This still means the same thing. It's just written differently. Now let's have a look at calculating 4, then brackets. Inside of those brackets, 3 times 2 minus 1, close the brackets, to the power of 2. Now here I've got a full spectrum of the order of operation once again. So we're going to use BODMAS and we're going to work with inside our brackets first. Inside our brackets, we see that we have to multiply first. So rewriting this, I'm going to write 4, and inside the brackets, 3 times 2 is 6. So I'm going to have 6 minus 1, and then to the power of 2. Now I'm not done with inside of the brackets yet, so I'm going to now use BODMAS and I'm going to continue with the brackets by subtracting. 6 minus 1 will be 5. So now I've got 4 bracket 5 to the power of 2. Now I still have that to the power of 2. So I'm now going to use BODMAS and I'm going to do my orders. 5 to the power of 2 is 5 times 5, and that's going to be 25. So now I've got 4 bracket 25, which is just another way of saying 4 times 25. And now I'm just going to use BODMAS again. I'm going to multiply, and I'm going to get my answer, which is 100. Now let's calculate 10 minus 5 over 5, which is another way of saying 10 minus 5 divided by 5. So here we treat the numerator and the denominator separately. This is very important. And we're going to put all the terms of the numerator in a bracket and all the terms of the denominator in a bracket, just to be safe. So I'm going to rewrite this, and I'm going to say brackets 10 minus 5 divided by brackets 5. Even though I've only got one term, I'm still just going to put that in a bracket just to be on the safe side. Now I'm going to do my bracket first, and I'm going to subtract. 10 minus 5 is 5. And now I've got divided by 5. And here I have another identity. Anything divided by itself equals 1, always. So 5 divided by 5, or 5 divided by itself, will equal 1. Obviously, when we do these calculations in school, we're not going to necessarily rewrite the expression or mathematical sentence with brackets. We are going to work straight with that fraction. So if I have that 10 minus 5 divided by 5, I'm actually going to do this. I'm going to say, I'm going to start with my numerator first. And I'm going to say 10 minus 5, which is 5, divided by 5, like so. And now I can just say, okay, well, then 5 divided by 5 is 1. So I don't need to go and necessarily rewrite the sentence, but if it helps you just to understand how the underlying math works, then rewriting isn't a bad idea. Though this is actually how we should be doing it eventually, basically training wheels off. Now let's calculate 5 minus 5 over 3, meaning 5 minus 5 divided by 3. Again, I'm going to treat my numerator and denominator separately, all my terms inside the brackets. Let's rewrite this as 5 minus 5 in brackets divided by 3 in brackets. Now I'm going to discard that bracket of the 3 because it's only one term. There's no orders, there's no anything. And I'm going to have 5 minus 5 in brackets divided by 3. Now I'm going to use BODMAS. I'm going to do the bracket and I'm going to subtract. 5 minus 5 equals 0. Now I have 0 divided by 3. And here's another identity. This identity tells me that 0 divided by anything always equals 0. So 0 divided by 3 will be 0. If I'm going to do this straight on top of the brackets, I'm going to have 5 minus 5 over 3. So I'm going to first do 5 minus 5. 5 minus 5 is 0. And 0 divided by 3, using my identity, 0 divided by 3 is 0. Now let's calculate 9 minus 5 over 2 times bracket 1 minus 1. This one's going to look a little bit more complex when I rewrite it, but again, I'm going to treat the numerator and the denominator separately, all my terms in brackets. So I'm going to have 9 minus 5 in brackets divided by brackets 2 nested brackets 1 minus 1, and then I close my big brackets. Let's work with our 9 minus 5 first. I'm going to use BODMAS and I'm going to subtract with inside that brackets. So I'm going to have left 4 divided by, and then I've got my nested bracket setup. Now I'm going to do my inside brackets first, and I'm going to subtract. 1 minus 1 is 0. So now I've got 4 divided by 2 times 0. And here I know I'm going to use my identity. 2 times 0, anything times 0 is 0. So I'm going to have 4 divided by 0. Another identity, multiply or divide. The identity tells me that anything divided by 0 now equals undefined. So 0 divided by anything is 0, but anything divided by 0 is undefined. Let's have a look at how we're going to do this one while working with the fraction. So we have 9 minus 5 over 2 times 1 minus 1. Okay, so working with my numerator first, I'm going to have 9 minus 5 is 4 over 2 and 1 minus 1. Now I'm going to work with my inside bracket, 4 over 2 times 0. I know that 2 times 0 is 0, so 4 over 2 times 0 is 0. And this is going to give me an undefined. Again, here I'd just like to show how we can use our square brackets instead of the rounded brackets for our larger brackets, with our round brackets for the nested brackets inside.